Let's talk a bit today about factoring quadratic equations using the AC method, specifically when A is equal to 1. So maybe further down in Algebra 2, you'll learn on using the AC method, maybe even tomorrow on using the AC method when A is greater than 1. But for today, we're going to focus on factoring quadratic equations just when A is equal to 1. So let's just recall that a quadratic equation in standard form is going to be written as y equals ax squared plus bx plus c. So remember, a quadratic equation is an equation where the degree, where the highest degree is 2. Let's keep that in mind. So we're going to be focusing on factoring quadratic equations, mostly trinomials today. So in standard form, we see that it's written in ax squared plus bx plus c. We're going to focus just on, again, when a is equal to 1. So some examples of these would be 1x squared plus 5x plus 4, where our a value is the coefficient next to the x squared. Our b value is going to be the coefficient next to our variable with a degree of 1, right? Because 5x is the same as 5x to the first. So b is going to equal to positive 5. And for c is going to be the constant here. So c is going to equal to 4. And so when you're using the AC method, you're going to be looking, again, let's look at these letters here, A and C. So if I want to factor this quadratic equation, let me just write y equals 1x squared plus 5x plus 4. I want to be able to factor it into two separate binomials. So think about your do now from today when we had x plus 2 times x plus 3. And once we use a distributive property, that gave us a value of x squared plus 5x plus 6. So factoring would involve us doing the opposite, from getting it from a trinomial into two binomials. So the AC method, we're going to be trying to see what two values. Let's multiply A and C. So 1 times 4 is 4. So what two numbers multiply to 4 that add up to the B value, which in this case would be 5. So what two numbers multiply to 4 that add up to 5? Well, you can list out all the factors of the C value, or for this example, be 4. So all the factors of 4, 1, 2, and 4. And what I'll notice is 1 times 4 gives me 4, and 1 plus 4 is equal to 5. So if we were factoring this into two binomials, I'm going to take those two values that we had, which were 1 and 4, and write them into our two binomials. So x plus 1 times x plus 4 should give us the value of x squared plus 5x plus 4. How can we double check that? Well, we can just go back to our do now, and we can try to simplify, or rather multiply these two binomials using the distributive property. So x times x gives us x squared. X times 4 gives us 4x. 1 times x gives us 1x. And 1 times 4 gives us positive 4. And I see here that I can combine like terms here, the plus 4x and the plus 1x, which gives us the value of x squared plus 5x plus 4. So when you're factoring a quadratic equation, when a is equal to 1, you might get 3 different scenarios here. Let's go over each one of these examples. So we have x squared plus 10x plus 21. So I see here that the a value, so a is going to equal to 1, b is going to equal to 10, and c is going to equal to 21. So in this example, a, b, and c are all positive. So this will be a little bit simpler for us to simplify here. So what two numbers multiply to 10? Actually, my apologies. Remember, AC method, so 1 times 21. So what two numbers multiply to 21 that add up to the value of 10? So again, you can list out the factors of 21. 1 goes into 21. 3 goes into 21. 7 goes into 21. And 21 goes into 21. Now, which pair of factors here add up to 10 then multiply to 21? Well, that's going to be 3 and 7. So positive 3, positive 7. So simplifying that quadratic expression would be x plus 3 and x plus 7. Your second example, we'll see here that A and C are positive, but B is negative. So whenever we have the value of B to be negative, but the C value is positive, that means we're going to have two factors that are going to be negative. So what two numbers multiply, what two negative numbers multiply to 21 that add up to negative 10? Now, because both factors are negative, that's going to be negative 3 and negative 7. So our binomials will be x minus 3 times, let's fix that x there, x minus 7. Negative 3 times negative 7 gives a value of positive 21 and add up to negative 10. Our third scenario, we're going to have B is, well, A and B are positive, and C is negative. So whenever C is negative, that means that one of our factors is going to be positive and one of our factors is going to be negative. Think about it. In order to get a negative number, one number being multiplied, it has to be negative, and the other one is going to be positive. So for all these three examples, I use the same coefficients just so you can see how each one of these examples will be applied. So if C is negative, that means one value is going to be positive and one value is going to be negative. So what two numbers multiply to negative 21 that add up to 4? So if you see here that the B value is positive, I know that the positive number is going to be larger because there's more positives than negative. So if I'm going to look at 3 and 7, they're 4 units away. So I'm going to take the larger integer, 7. And we're going to have our other integer to be negative 3. 7 plus negative 3 gives us positive 4. And 7 times negative 3 is going to give us negative 21. Let me elaborate on that one a bit further. Let's say it was x squared minus 4x minus 21. We could call this one case 4. So for case 4, we have B and C are negative. And so when you're factoring this trinomial, you're going to think what two numbers multiply to negative 21 that add up to negative 4, where the larger integer is going to be negative. So in this example, negative 7 and positive 3 are going to be your two factors. So x minus 7 times x plus 3 would be how you would factor this expression here, this quadratic expression.